PNGs are everywhere. They're used in design, programming, art, video editing, you name it. But what exactly is inside of a PNG? My goal was simply to create a program that could tell you all about a PNG and display it too. In order to do that, I enlisted the help of Rust. This project ended up being far more complex than I expected because PNGs not only compress themselves, but they also prepare themselves to be compressed. This resulted in a lot of really cool looking images. The first goal was to just create a tiny little PNG. Of course, when you start small, it makes it a lot easier to debug any issues that you have. Once I created the PNG that I wanted, I used Rust's FS module in order to actually get the bytes out of the PNG. And just like that, I have everything inside the PNG that I need. I created a function called find sequences that helped me really early on. The idea with find sequences is that I can look for any particular chunk and then get the data from it that way. Little did I know though, that was a completely awful approach. There was a huge issue. Two issues, in fact. But first, you need to understand what a chunk is. A single chunk can be broken down into 4 different pieces. First is the length, which tells you how long the data is. The type is the actual name of the chunk. The data is the core content of the chunk. The CRC we won't really be using in the code, but basically it's used for detecting whether there is corrupted data in the file. PNGs are quite literally just a long series of chunks with different jobs. There's more than 20 different types of chunks a PNG can have in it, but there's only 4 essential chunks. For the purposes of this video, you only need to know 2 of those 4 chunks. First is the header, or IHDR. Stuff like image height, width, what kind of color profile it has, and whether it has transparency, that type of thing. Data is the second chunk that we care about, or IDAT. This is the actual data that tells you what the image looks like. In other words, the order of the pixels, their colors. An image must have 1 or more of these chunks. This all leads us back to the problem with find sequences. Firstly, there is nothing stopping chunk names from showing up in a random series of bytes. When we're talking about the actual image data itself, this can cause false positives when I'm trying to search for a particular chunk. Also, when you find the name of a chunk, some chunks have a variable length, and the length of a chunk is defined before the name. So I would effectively have to find the name, then go back, find the length of the chunk, and then step forward some amount of length. And it was just weird. Eventually, I landed on a far better solution. I would walk across the PNG from beginning to end, storing each chunk I find into a hash map. For this, I created a function called getChunks. First, I set up some initial values, the most important being an empty hash map called chunks. Then, for each chunk I find, get its length, type, data, and CRC. This should sound familiar. Once we got all of it, we loaded up into an instance of chunk. Then we slapped that chunk instance into the hash map using the chunk's type as its key. Great news though, I was able to get it working. At this point, we could see every chunk of the image in a tidy hash map. There's the IDAT. There's the header. There's the IEnd, which we didn't talk about, but it's basically the end of the PNG. It's worth remembering that you will make code that's junk. It will be suboptimal, it won't work. Perhaps if I had read the PNG specification a little more intensely, I could have maybe come to the solution a bit faster, but also I could have just gotten bored of reading the specification and then just not done the project at all. Sometimes it is better to just jump into something, especially if you know you're just learning, and understand that you're gonna make junk and that's cool, like you learned something from it. By this point, I had to be almost done, right? I mean, I have all the chunks, I have all the data there right in front of me to look at. All I had to do was look inside of the IDAT chunk and just see all that sweet, juicy data. It's all right there, except, wait, hold on. When I looked at the data chunk, I expected to see a series of colors, each with their own RGB values. These would be neatly arranged for my dumb lizard brain to understand. I would have everything I needed to complete the project and talk about how easy it was to do on YouTube. I was wrong. This is actually what I saw. For all intents and purposes, this was complete gibberish to me. I looked at the PNG spec and got to work on figuring out what in the world was happening. So you might think that the data in a PNG is like a book, but really it's more like a weird disassembled toy that's put into a box. See, when your favorite image editor decides to create a PNG, it will run the image data through an algorithm that will prepare it for being compressed. Once it's disassembled, it's put into a box. We can call this box compression. The data inside the PNG is actually compressed, like a zip file. Really what I needed to do was just take that creation process and do it backwards. First, I would need to unbox it, meaning I would need to decompress the data. Here's what an image looks like normally, and here's what it looks like when it's been decompressed but not reconstructed yet. It looks pretty wild, honestly. But what's interesting is that the second image is easier to compress than the first image. Perhaps you'll hate me for this, but I used a library to decompress the data. Compression is not something that's unique to PNGs. Also, I wanted to get this project done within the fiscal year. As a result, the decompression portion, aka taking the things out of the box, was really straightforward. Basically, I take all the data from the IDAT chunks, combine them together, then decompress them. Don't be afraid to use a library sometimes. Remember what your goal is. In my case, I wanted to learn how PNGs work, not compression, so I just skipped this. That way I was able to get this project done a lot quicker. Choose your battles wisely. At the end of this, I opened the box and pulled the metaphorical pieces out, but I still needed to actually put the pieces together. Now this is great and awesome. Progress is being made, and surely I must be in the final stretch. But little did I know that Reconstruction was about to whoop my Reconstruction was the ultimate test of my patience. For reference, it took about 2 weeks to get to the point where we are now in the project. It took another 2 weeks to get Reconstruction done. The goal of Reconstruction was simply to reassemble the PNG data that we got from the proverbial box. Before we go any further, we need to understand how filtered PNG data works. Let's say that we've already completed the Reconstruction and we have the data in front of us. This is what it looks like when data is reconstructed. This is a 2x2 image, which has 4 colors total. Each color has 3 values, red, green, and blue. It has 2 scan lines of colors. A scan line is a fancy word for a row in an image. Now this is what the image data looks like when it hasn't been reconstructed yet. Notice how there's an additional byte being added at the beginning of each scan line. These are filter types. They are instructions telling you how to put the image back together. So to summarize, we are basically using those values to transform this into this. But how do you get there? How does that work? To be honest, telling you how it got done is a whole video in itself, but I will give you a high-level perspective from my code. I created a function called reconstruct image data, which looks at the disassembled pieces, including the filter types, and reconstructs the image in a final colors buffer. We initialize the current filter and an empty final colors vector, which will store the reconstructed pixels. Now we loop through every byte in the filtered image data. If we are at the beginning of a scan line, then we know we are at a filter value. We set the current filter to that filter. Otherwise, we reconstruct the byte. Notice how much stuff we're throwing in that function. Not only is final colors eventually going to be our final output, but its intermediate steps are inputs for filtering bytes. This tripped me up hard when figuring out reconstruction. The byte is the current byte we are looking at in the filtered sequence. Then there's the header data. This becomes essential here because it helps us understand pixel and scan line size, which all go into reconstructing the byte. Finally, we pass the filter type. Inside of reconstruct byte, this is where it gets really hairy. I'm just going to say that we perform specific operations on the byte based on what the filter is. The PNG spec tells you exactly what to do when you are faced with a specific filter type, and I copied that process. There were a million gotchas while putting it together. Okay, so that was a lot. I want to explain all of these things to you because I want you to see why it took me so long to do this. I ended up having to pretty much break all the things down on my iPad and just see, okay, how do I do this filtering thing? This was a long and grueling process. There were many days where I just simply showed up, tried to get some of it done, whether that's just finding an approach or seeing how I could expand on a current one. Sometimes I just thought. Other days I just didn't show up. After 2+ weeks of trying to figure this out, I was finally able to display an 8x8 image which used all of the filter types. Remember that there will always be a time where you're stuck on something for a whole day. In my case, it was like this ad nauseum for 2 weeks. But I promise you, if you keep going, you will find some sort of solution. Whether it's weird or, a workaround or just something to get you through it, you'll figure something out. And you'll figure out a lot of broken ways to do it too. But that's how things are. It just hinges on how badly you want to solve the problem. But yeah, I got filtering all figured out. That was the hard part. Now I got to do the celebratory cleaning up. As you can see, PNGs are a whole thing. I gave you a ton of information on them, and yet I've barely even scratched the surface. I didn't even touch any of the optional chunks that come with PNGs. Regardless, I had a great time. I had to kind of pick up Rust again. It was very interesting to just figure out the language again and then also figure out PNGs themselves. I would definitely recommend just going and picking a file type of your choice. Just dig into the bytes. A lot of programming languages let you do that. If you enjoyed this video, please let me know what other file types you might want to see. I could dig into that as well. That's pretty much about it though. I appreciate you getting this far if you did, and thanks for watching.